Thank you, ma'am.
Presenter as well as for hosts.
Thank you, ma'am. Ma'am, is my screen visible?
Yes, your screen is visible, Diksha.
Good afternoon, everyone. Thank you, ma'am, for giving us such an opportunity to present and explain blockchain visualization. The motive of the next 10 to 15-minute session is to visualize what is hash, blocks, block structure, and what is basically a blockchain, how actually blockchain works. So before that, before looking at what is actually a block, or a blockchain, let's understand what is a hash. As ma'am has already told that hash is basically the heart of any cryptographic concept. Hash is a mathematical function which converts an input of arbitrary any length into an output of fixed length. It is basically an irreversible process. That is, the data can be converted into hash, but the hash cannot be converted back into the data. As you can see, currently the system has is having blank data. Hence, for the blank data, we are having the corresponding hash. Next, generally, the blockchain uses SHA-256 hash in order to compute its hashes. Let's see how properties of hash changes. Just a second. Suppose I have I've changed some data into the file, so the corresponding hash will also change, whereas the length of the hash will remain same. So let's change only a single word in the data. So you can see the complete hash value will change, whereas the length of the value will remain same. Again, we can see for the same word welcome, the hash remains same. So this is the concept of hashing. Next, let's visualize, as told by in the morning session, told by Sofat sir, about the blockchain structure. Let's visualize blockchain structure.
Diksha, I will just interrupt for a second. People are asking which visualization tool you are using for this, so you can just tell them you are using your browser or whatever demo you are using.
This is basically a demo created by us for using our code. This is basically a front end created by us only in order to show the visualization of how what is
So,
actually a
so yes, all participants, we had created this demo session using some code. So if you want to have this code, we can share with you so that you can have a demo session with your students as well. We can share this code for sure. But right now you're not using any platform or any browser for specifically for this.
Yes, ma'am. It is working on my local host only currently.
Right. Thank you, Diksha.
So let's continue. So next, the concept of a block. This screen corresponds to the block structure, as told by ma'am earlier. The block consists of a nonce, a data, and hash. So as you can see, the current color of the current block is basically green. This indicates that the block has been mined. That is, the mining difficulty in order to mine the block has been reached by the system. So as we can see that there is currently no data in the block. So if we substitute some data in the block, the color of the block completely changes to red, and the corresponding hash also changes. But the system takes it as an invalid block, as the mining difficulty is not reached. In order to add the block into the blockchain, the miner needs to mine the block. Let's mine the block. The system will take some time in order to mine the block. How it is done? First, let's see. The mining difficulty is termed in terms of hash. That is, in this current system, the mining difficulty is defined as four zeros prefixed to the hash of hash. So in order to achieve the mining difficulty, the system needs to get four zeros prefixed to the hash. So, so how this is done? Let's see it manually. Suppose we have this data. The system will randomly check the nonce, like we put one. Will system will randomly put the nonce, check the nonce, and it will add it to the data, and corresponding hash will be generated. Next, as the as the mining difficulty is not achieved, it will again check it. No, the mining difficulty is not achieved. Next, again. So subsequently, the mining difficulty is checked and mining difficulty is achieved. Next, when the mining difficulty is achieved, the block is mined. This is why it is said that it takes approx 10 minutes to actually mine a Bitcoin into the blockchain. So, any doubts till now? Or shall we take the doubts at the end of the session? Next, I would like to request my co-presenter, Shubham, to continue with the rest of visualization. Shubham, can you please continue with the visualization? Hello?
I'm
Yeah, yeah. Please continue.
just a minute. Hello. I'm audible to every. I'm Shubham.
Yeah, please.
Yes, you are audible. You can go ahead.
Ma'am has already explained you the concept of hash. Ma'am has. Now I will try to tell you that how these blocks are actually clubbed together to make the form of a blockchain. Merging of the blocks is a bit similar to just like that of the linked list. As in linked list, we know that every node saves the address of the coming. Similarly, in the blockchain, what we do is the hash of this node, the first block, will be saved. The hash block of the and so on. We are trying to create a link between the different blocks and hence forming the blockchain. There might be the many confusions till now we used to face when we were just going or starting with the blockchain. Like to clear those doubts as they were being asked in the chats also. What is the nouns? Nouns is just the random number here which is being created. Difficulty level is this number of zeros that we are starting with. See, the hashes are
Hello.
starting with the four zeros.
Hello. Diksha. Sudhanshu, your voice is very low. We are not able to hear you at all. Sorry for the
Now am I
interruption,
audible?
but yeah, now it's okay. Thank you so much for sorry for the interruption, huh?
No issues, ma'am. Thank you. So I was just trying to explain that what actually the nouns is. See, whatever, suppose this is the data. If this is the data, then obviously it will be having the same hash, right? We cannot change, it is not possible that with same hash, we can get different, uh, for the same data, it is not possible that we can get different hashes, right? So what, for that purpose, we are taking this field, which is in our hand, we can change it with the random numbers so that actually the required difficulty level can be met out. Mine, what happens is it keeps changing the value of nouns and calculate the hash. Change the value of nouns, calculate the hash. It will do as many times till it reaches the required difficulty level. Required difficulty level means hash should be starting with a prefix of certain number of zeros. In this case, it is 4 zeros. As it is starting with the 4 zeros means we have meet out the difficulty level. Hopefully the concept of and the hash is being cleared. Now, the other common doubt that appears is where the blockchain is actually being saved. So, blockchain is being actually here. It is possible. This is a small blockchain system containing of the three members, peer A, peer B, and peer C. All the peers are having the same copy of the blockchain. soon as the new blocks will be the copies, it is their responsibility to get it updated along with the others also. Now, the other question that might arise is how the blockchain is really a very tampered proof. Let's see. Suppose peer A is a malicious person or a malicious miner who wants to make some changes in the block just for his own benefits. Might be in the block 1, might be in the block 2. See, as soon what happens is the hash of this block changes. Hash of this block changes and it is not meeting the difficulty level. So it became red. Hence, it is quite obvious that some malicious activity has happened from this block. In order to hide his malicious activity, peer A might try to mine this block once again. Hello?
Hello.
Some disturbance?
Hello?
Or shall I continue?
Yeah, sir, your voice is not audible. It's very low.
Okay. Ma'am, is it now audible?
Somewhat audible, but not very clear.
Ma'am, is it audible?
Yeah, it's audible. You could be quite like bit. It should. It's not. Sometimes it's bit low, but your pitch is very very low. I think be on high pitch while speaking.
Ma'am, should I continue?
Yes, you can please continue.
Okay, ma'am. Thank you. So, in order to hide this malicious activity, that the change he has, the peer A has done in this block, remine this block. But this will not be sufficient for him to just prove his malicious activity right. He will be, as soon as he remine this block, but it's still the problem will be persisting because the successor nodes will be not containing this previous hash of this block, right? So what is the solution? Solution is in order to perform any malicious activity, peer A will have to mine all these block, remine all these block. It is very lot or a high amount of the computation, right? Again, as soon as he mines all these blocks, right, the work will still not be done. Why? Because the copy of the blockchain that is being saved with the peer A will not match with the blockchain copy that is being saved by the peer B as well as the peer C, right? So what he needs to do is he needs to convince either peer B or peer C to make this that he has done in this block. If he is successful in convincing peer B or peer A to do all these computation activities for him, then in that case, 51% attack, one of the most common known attack of the blockchain, might be possible. But theoretically, only this attack exists. It is not possible in practical to take out. The reason being, cannot convincing the peer A or peer B seems easy over here because it's just the three individual or the three organizations being creating the network. But in the real world, there will be obviously the hundreds or the millions of the users, and convincing them means you need to have a power of 50% of the computation power of the whole blockchain system. So that's it. If any questions still.
So, is there any doubts? You can please ask.
So thank you, Diksha and Shubham, for this visualization, for all the concepts we have learned in this fundamentals session. There was one question